Alright, we are on day 4, so make sure you have your foldable out. Even if you didn't have your homework done, you can continue to work with us because we're going to do all of it together today. What we have done so far, first thing we did on day 1 was we were given data. We were comparing 2 sets of data. We created a scale and we plotted them to make a scatter plot. We made a scatter plot. Second day, we then look at our scatter plot and we decide if there's correlation, if there's gaps, if there's clusters, if there's outliers. We then drew our line of best fit in between our dots, which is going to be kind of like our slope, or I keep saying the word trend in class, like our plot is trending this way, all our scatter plot. You can also couple line your trend line. Today, we are going to learn how to write an equation for that one. So, what I need you to make sure you turn to in your foldable, we are going to turn to equations of line of fit, the very last page. So open up your foldable. You should be on this page. Go get it, have your pointer out. We're going to say as part of responsible, you just bring everything. Okay, and we have input on this page. David, open up to the right page. Donovan, to the right page, please. Dylan, we're on this page. Alright. In order to write an equation for our line, we have the 6 steps. And this is for everything. We plot the points in a coordinate plane. We draw our line of fit. We choose 2 points on the line that we drew. We find the slope. We estimate the y-intercept, and then we write it as y equals mx plus b. That's what we learned last semester. Y equals mx plus b. This is the equation for finding slope. So, we're going to do a quick review on how we find slope. So, you have a little bit of space right here on that yellow part, right underneath. We're going to find the slope. So, go ahead and write these coordinates in. I'm going to do number 1 with you, and then I'm going to throw a sucker out for number 2. So, for number 1, I want to find the slope between the points -3, 3 and 0, -1. When we do this, remember to find slope between 2 points. In here, I have x and y. This is x2, y2. Yes, Kemper? You're just going to put right here in these blanks. So remember, when we have coordinate points, we always go x first, y. We need 2 of them to find slope. My equation, like we have right up here, is y2 minus y1. So y2 is -1 minus, and my y1 was 3. Dylan, opening up your thing, doing this with us. Not of it. Opening up, doing this with us, bud. Then we do our x. Remember, because it's rise over run, so the y's are on top. My x2 is 0 minus my x1, which was -3. Now we solve this simple subtraction problem. 1 or -1 minus 3 is -4. Because we had -1 and then we went 3 more backwards. So if you think of it like on a number line.
Well, that was a +3.
Well, it is a +3, but we're subtracting. So if you look at this number line, I'm here at -1. So when I subtract 3 means I'm going to go 3 this way to the left, getting smaller. So -2, -3, we'd be at -4. we now have 0 minus negative 3. When we're minusing a negative, we make them positive. Subtracting a negative is like adding a positive. So this would be 3. Our slope is negative 4/3. We leave it that way. Okay, I'm going to pause. I want you guys to find the slope for number 2. There's the little points. Use exactly what we did. Same thing, I'm going to pause. I'm going to let you work, and then we'll look at it. Aiden, let's start with you, bud.
Okay, so you got to do y2 minus y1, which would be 4 minus 1.
So 4 minus 1, that's y2, that's y1.
Then you do x2 minus x1, and then that would be 2 minus negative 4. And
Okay.
then you make the 4 positive, and you add to it.
Okay, so minusing a negative is like adding a positive.
And then you get 3 over 6.
4 minus 1 is 3. 2 plus 4 is 6.
And then you simplify it to half.
Good. 3, 6. We simplify because 3 is common. It becomes 1. Whoops, I got rid of 6. Will become 1/2. Good job, man. Okay. So here's what we're going to do today. We are going to go through almost this whole process for today's goal of writing the equation of our scatter plot. So here's our blank example. All they've done is they've given us all the data. They said, hey, I went out, I want to find out if there's any correlation between, as the years are going on, every year they start tracking, every year, how many black bears were killed on the road. So it's roadkill. So we're seeing how many bears were killed as the years progress. So let's look at our practice. What do I have to do first? What's the first thing to do? Dusty?
Find the highs and lows.
Yeah. So I know this year is going to be my X. Black bear roadkill is my Y-axis. So we need to graph this. I'm going to look and say, how many lines do we have? 1, 2, 3, 4, 5, 6, 7, 8, 12. Okay, we always make these 12. Okay? If I find my high and low for the years, my high on my x-axis is 17, my low is 1. Am I going to be getting away with saying every line is worth 1? We're not going to get that. But I'm going to show you how we're going to cheat with this one, just a little bit. This one, because our numbers are pretty small, I'm going to go ahead and I'm just going to make my scale go by 2s. We could do 1.5, but here's the problem. I see the years go by 1. I know that's the pattern. It's going by 1, 1, 1, 1. So if I need this a decimal at all, I'm really going to be guessing part way between everything. So for my x, here's 0. I'm going to go ahead and say I'm going to go by 2s. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And it actually is pretty good if we go a little more, because this will let us make interpretations. Make sure you're doing this with us. Donovan, up. So you can do the work. You're not going to get better by sleeping. So, my first thing is, I had to label my x-axis. So I start at 0. We always start at 0, and I'm going up by 2. My y-axis is going to be the one that is different. For my y-axis, we'll do it in purple. Dusty was telling me we have to find our high and low. So what's the highest number of black bears killed?
Oh, that's
129. This is our high. What was the low number? 30. Okay. Remember, our first thing what we had to do to, gentlemen, I'm not going to keep stopping because you guys are just talking. I know. I want you to focus up here though, because other people are being distracted then. Okay, we're going to find our range. That's the first thing you have to do. So my high was 129. And I'm going to subtract my low of 30. That means my range was 99. Meaning my graph is going to cover 99 for its data. What do we do next to find our scale? Actually, Kimber, you were having trouble with this, but you were doing it right yesterday. What do you think we do next?
Divide it by the number of lines there are.
Absolutely. We have 12 lines, so I'm going to do 99 divided by 12. Oops, that's male. So, let's see. Calculator. Alright, 99 divided by 12, 8.25. So our scale has to be at a minimum 8.25. Is that what we want to make it? No, we don't want to count out 8.25. So what should I make this? Ooh, I like that. So whoever said 10, some people are thinking 9. 9's really close to 10. 10's a simple number. So our scale will be 10. If we go to our graph, here's 0. Before I jump by 10, remember, my first line wants to be my lowest value. And we said our lowest number was 30. So I'm going to write 30. Why did we go to 10? Because we found our scale was 8.25. So we add a smallest number. Our lines have to jump by 8.25. Well, we want to estimate. I don't want to count by 8.25. I don't want to go 16.5, 24.75, and keep doing that. So instead, we can round up. I could have rounded to 9, but 9's really close to 10. And 10 is a landmark number that's very simple. So we chose 10. If you were to use 9, Dusty, on yours, it would have been okay. Your graph would have looked a little different, but it would have been okay. All right. What do we do when we don't follow our scale on the very first line? Yeah, we do our little squiggly line. It shows anyone reading our graph that we compressed our information for a little bit. Then I'm just going to go ahead and do my scale. 40, 50, 60, 70, 80, 90, 100, 10, 20, 30, 40. Awesome. We've now done the most difficult part so far. We've done the scale. And it actually didn't even seem that bad when we knew the steps. We are then having to, if we look back in our foldable, where did I put mine? If I look in my foldable about graphing scatter plots, determine the scale. We did that. Step 2, title the graph and label the axis. Okay, what do we call this? Huh? Sure. Black bear. Black bear. Kill. So we have Black Bear Roadkill as our title. On our x-axis, what was that 02468? That was our years. What was our 30, 40, 50, 60, 70, 80, 90? Black bears kill. black bears killed. We now have our coordinate graph set up. We've labeled the title, we've labeled the axis. We now go ahead and
I'm not sure. But is this like actually like facts? Like 17 years, a lot of black bears get killed by cars.
well, so they're saying like when they started tracking the data, the first year 30 bears were killed. The second, 37 were killed. The third year, 46 were killed.
I feel like a car, black bear is living to take care of a car.
I don't know. Alright. So what do we do with our What do we go ahead and do with our data next? We're going to plot it. So, this should be something everyone can be doing right now. I'm going to pause our video here in just a second. But I'm going to plot each one of these points. I'll use green. So I'm going to go year 1 should have been 30. So here's 0, 2. 1 is in the middle. There's 30. I'm going to put a dot on it. Year 2 was 37. So it's probably somewhere in there. Year 3 was 46. Should be in there. Year 4 was 33. Ooh, 33. Damn. Okay. I'm going to pause our video. Quietly go ahead and plot all your points for me. Alright, so if you look, I've now got all my points plotted on there. Looks like when I first started, when I wasn't zoomed in as much, my dots are a lot bigger. Let's do the first 3. 130. 237. Alright. So, gentlemen, I think I'm going to have to move our seat. We'll just spread this out. We got lots of space. Okay, yours should look similar to mine. You have your dots. Let's go ahead and do a little bit of quick talking here. Is there, the third thing we're always supposed to do was identify correlations. What type of scatter plot do we have? Is it a positive, negative, no correlation?
Positive.
Positive. So I'm already going to say over here, positive correlation, which tells me as the years go on, got dry there. As the years go on, more and more black bears are being killed. Every year, more black bears are being killed. Is there any gaps in our information?
No.
Don't really see any gaps, so I'm just not going to put anything, or you could say no gaps. How about any outliers? Doesn't look like it. If I look at my trend, it looks like we're going up like this. Everything kind of is packed in there. Clusters. Is there any clusters?
No.
So I'm going to say no gaps, clusters, or outliers.
What's that?
Outliers. Remember, outliers are the ones that lie outside our information. So if our trend line was like this, and we had a point over here, we'd be like, whoa, why is that way different than everything else? So, now, we're going to get through this, and you're going to be able to have work time. We got to focus. We're almost done. Like, we've done a lot. We've just put almost 2 days right away, and the third day is going to take, like, no time. After I've graphed this and identified the correlation, gaps, clusters, outliers, we then want to draw our line of fit. Does this one have a line of fit? Yeah. Because we identified it as a positive correlation. So, you use a straight edge. Please do not freehand this. You need to make it straight. On your test, you can use the side of your notebook, your planner, your badge, another pencil. But,
what if you're really good at drawing?
Nope.
You're not have to do the line. That's you are.
New.
Fire alpaca. Military. Military. Do we have homework? Military. Thank you very much.
Alright. Alright, so focusing up here. Okay, if I look at my line, okay, I'm going ahead and draw my line. Yours might be just a little bit different. But now we have our line. We're going to do the last part for today, and we have to write the equation for the line. That's going to be the last thing you're going to do for today. That's what you're going to do for your homework. In order to write the line, it's simple. We only need a couple things. Our line will be written as y equals mx plus b, where we already know the only thing that we have to replace is instead of putting an m down, we're going to say what the slope of the line is. And instead of the b, we write what our y-intercept is. I'm going to give you a hint. We probably should have done one like this. But if we look at this, our y-intercept is going to be one that we will estimate on today's assignments. We're going to look at our line and say, okay, where does it cross our y-axis? And where do we guess it would be? If we look at ours, we also have to use a little common sense. Look at our data. We started with year 1 was 30. So when we started with year 0, what would that y-intercept have been? If we didn't have a year 0, it would have been, what did you say? That's 0. This data, when we give you this example, we didn't think of that part as well. But your y-intercept, and I'm telling you, is going to be 0 on today's for the example. The reason why is because we said year 1, we're at 30. So when we're at year 0, we didn't track any information, there was none. And we know we can't go negative. We can't say, hey, there was -5 bears born. We actually killed -5 bears. Our cars were driving, they hit a bear, 2 bears popped out. No, that's not going to happen. So, there you go. So, we're going to have our y-intercept be 0. We can know that. I'm going to go right here and say y, or not y. We're going to say our b is going to equal 0. And it kind of makes sense. If you look at my line, it kind of looks like where it's going to cross. It would have crossed right here at rim 0 because this is squished down. If this would have been up, it probably would have been. The biggest thing we have to learn today is how to do the slope. And this is what you're going to do. We need to identify 2 points on our line that we drew. So I'm going to highlight them with yellow. I'm going to start here, and remember, we want points that we know for sure. Easy ones. So when I'm looking through here, like right there for sure is an easy point. I look through, I'm going to say, actually, well, we don't know what that is because that was squished down. Oh, we could. Well, that's not on my line. It has to be on my line. So if you didn't hear, Sydney, don't break my rulers or bend them. Sydney just said, hey, can we use 130 because that was in our data, we know it, but it's not on our line that we drew. So I'm going to follow my line. I'm going to say this one's really close as well. So we're going to count that. We're going to write down our 2 points now. This first point right here is at 1070. Our second point is at 18 and 120. I've now gone through my line and I've identified 2 points. Yes?
What if you don't have like the same points?
If your points are different, just do the same steps as me. So you have to be looking at your line. Follow your line. Find 2 points. Remember, yours might be a little bit different than me. But I'm showing you the steps. You're going to identify 2 points. Now we identify slope. Y2 minus Y1. So for me, it was 120 minus 70. X2 minus X1. 18 minus 10. When I solve, I'm going to get 50 over 8. That can simplify by dividing by 2. I get 25 over 4. And I cannot simplify anymore. This was my slope. So my last thing I have to do is now write my equation. I'm going to write it as y equals, so I'm going to say y equals. What was the slope you end up finding through your 2 points? Mine was 25 over 4. X. We already said our y-intercept is 0. So am I going to add anything on there? Am I going to say plus 0? No, I don't have to. That is my equation. That is what you will do for today's assignment. Your homework assignment for tomorrow. Oh, we're almost out of time. Day. Your homework 1, 2, and 3. You have to write the equation based off your line of fit.